15D is all about the locus which forms the shape of an ellipse. So know that the Cartesian equation of an ellipse looks like x minus h squared over a squared plus y minus k squared over b squared, and that's all equal to 1. H and k will give us the center point of the ellipse. A kind of gives us, I guess, the length of the horizontal radius in a sense. And B gives us, again, in less mathematically rigorous terms, the vertical radius of our ellipse. So from the center point straight down to where it touches the ellipse. Notice that the x's and the a, h go together, and the y, b, and k's go together. Let's use this information to find the equation of the ellipse given in the diagram below. Notice the ellipse has a center of 0, 0. H must then be 0, and k is also 0. Well, let's look at the horizontal distance between the center and the edge of our ellipse. Just one side of that is 4, so A is 4. B would be the vertical distance between the center and then straight up to the edge of the ellipse. That looks like it's about 5. So then I can find A squared and B squared and sub everything into the equation. I should get x minus 0 all squared. A squared would be 4 squared plus y minus 0 all squared over 5 squared equals 1, always on the right hand side. And then we just square the 4, get rid of the zeros, and we'll get x squared over 16 plus y squared over 25 equals 1. Okay, so where does this equation come from? And what about the locus of a point that forms an ellipse? So an ellipse can be defined as the locus of a point P that moves so that the sum of its distances from two fixed points, often known as focus points, is equal to a positive constant. So notice in this ellipse here, I have 2 points, one in red, one in blue. It's like there's a string connected to these points and my ellipse. Notice that no matter how far around the ellipse we go, that length of string will in total remain the same. Even though the blue part gets a little bit bigger or smaller and the red part gets a little bit bigger, or again, we see that the total length of string here will always be equal to some constant number. First question. Consider that we have 2 focus points, F1 and F2. A point P, xy, moves such that the sum of its distance to F1 and its distance to F2 is always equal to 8 units. So we think this is going to form an equation that looks like an ellipse. So as always, let's write this rule that we've been given in simple words and then incorporate more mathematical notation. So 3 parts that are key. We have the distance from P to F1. And F1 is minus 2, 0. Plus, or the sum of this with the distance of P to F2. So I can write plus the distance of P to F2, f2 is 2, 0. And again, if I refer back to the question, it says this is always equal to 8 units. So I'm just going to write equals 8. Then we use our distance formula to write this fully using mathematical notation. So I have x minus minus 2, that will become a plus 2, all squared plus y minus 0 all squared, plus on the distance, so the square root of x minus 2 squared, plus y minus 0 squared. That all is going to be equal to 8. I'm just going to tidy this up a little bit by getting rid of the zeros where I can. Now, before you go ahead and start squaring this statement straight away, if I square the left-hand side, this is going to get really, really messy. So we do a little bit of manipulation. Always remembering that in the end, we want to write this equation in the form of an ellipse. So how do I get these things with the square roots into an equation that looks like x minus h squared over a squared plus y minus k squared over b squared equals 1? Here's my hint for you. Take one of the square roots to the right-hand side and then square both sides. So I'm going to leave the x plus 2 all squared plus y squared on the left, and I'm going to take the square root of x minus 2 squared plus y squared. I'm going to take all of that over to the right-hand side just by subtracting it. Now we square it. Notice that the left-hand side is nice and easy. When we square it, we're just going to remove the square root. But the right-hand side, we have to work this out. There's a few more steps. So we'll have 8 times 8, which is 64, minus 2 lots of 8 times the square root of everything under that square root. Then plus, we'll negative the square root of everything underneath times, again, the negative square root of everything underneath. We will just get rid of the square root, and the minus will become a plus. So remember, if you want to break it down, you would use your FOIL steps to figure out the right-hand side. Okay, so now what I'd like to do is expand everything and simplify where I can. On the left-hand side, I'll get x squared plus 4x plus 4 plus y squared equals. On the right-hand side, I'm just going to bring the x minus 2 all squared and the plus y squared in front of my square root, just to make it easier to see a few things. So I have 64 plus x squared minus 4x plus 4 plus y squared. Subtract your square root, so minus the 16, etc. Now it's easy to notice that x squares will cancel, the 4's will cancel, and the y squares will also cancel out. I'm going to try and take the x's to one side, and as well as this 64. So I'll get 4x plus 4x, that will be 8x. Subtract the minus 64 to move it across, so I'll get 8x minus 64 equals, and I'll have my square root on the other side. Now, to simplify it, I can see I can divide by 8, so I might as well do that now. All right. Notice that I don't have a square root sign in my ellipse, so I need to get rid of that by squaring both sides. I'll get x minus 8 squared, and then I'll get minus 2 with my square root all squared. Expanding the left-hand side, that's pretty simple, straightforward. The other side, I'll do the minus 2 squared first. That will give me 4. But remember, you have to multiply your 4 by whatever is inside that square root sign. When you square something that's got a square root sign, the square root will disappear and you'll be left with whatever's underneath. So x minus 2 squared plus y squared. I'm going to expand that now. And then remember, multiply everything on that right-hand side by the 4. So I'll get 4x squared minus 16x plus 16 plus y squared. Okay, like my ellipse, let's try and get all the x's on one side as well as the y's. So I notice I can cancel out the minus 16x. And now let's put this x squared plus 64 equals 4x squared plus 16 plus 4y squared into the form of ellipse. So x squares and y squares on one side, and let's move the numbers to the other side. So I'll end up with 3x squared plus 4y squared. And on the other side by itself, I'm going to put the 64 minus 16. So I'll get 48 equals 3x squared plus 4y squared. Now notice I have a 1 on one side by itself of my equation of the ellipse. I want a 1 here, so I'm going to divide both sides by 48. 48 divided by 48 is a 1, and then divide the right-hand side by 48 and simplify where you can. So 3 divided by 48, well, that will give me 1 over 16. So I have x squared over 16, plus 4 divided by 48 is 12, so I have y squared over 12. This is great. This is the form of an ellipse. So I know the rule they gave me in words can be written as an ellipse. Now, if you want to sketch your ellipse, the center would be 0, 0. Your A is 4, and your B is root 12 or 2 root 3. It would look something like this. We're going to look at one more example if you're allowed to use your calculator to solve. So we start from the beginning and we write in words and then mathematical notation. Then we use our calculator and it will help reduce our steps that we need to take dramatically. So we know the distance from PXY to A, 1, 0, plus the distance from B minus 1, 0 to P is always equal to 4 units. Whenever you see the sum, you're going to think, okay, this might be an ellipse. In mathematical notation, put your square roots in here. So we'll have x minus 1 squared plus y minus 0 squared. And for the second half, we're going to add that to the square root of x minus 1 becomes a plus 1 squared plus y minus 0 squared. That's going to equal 4. Now, if you can use your calculator, what I recommend you to do is stop here. We want to try and get this in the form of an ellipse, but we know doing it by hand is a bit messy. So what you're going to do is you're going to solve using your CAS calculator for x. Not x squared, not y squared, because that gets really confusing on the calculator sometimes. So I'm just going to solve it for x. It also means I get to do some algebra, which is always a bonus. Okay, When you type this on your calculator, you get x equals 2 square root minus 3, all in brackets y squared minus 3, all over 3, something like this. Have a check yourself. Now we rearrange in the form of an ellipse. So we need some x squareds. We've got some y squared, so that's great. And I need my a, b, and the 1 on the side by itself. So the first thing I want to do is find my x squared. So let's square both sides. This is much nicer to square. Just be careful when you're squaring the right-hand side. So remember, do the 2 squared first, that's 4. The square root sign will disappear. And on the base, we will have 3 squared, that's 9. I would expand the inside of our brackets on the right-hand side and then gradually expand all of it. Times all the top by 4. Now what I want to do is get the x squared and the y squared to a side by itself. So I'm going to multiply the x squared by 9. Then I'm going to move the minus 12y squared to the same side as my x squared. Lastly, remember I want a 1 on the side by itself. So I'm going to divide both sides by 36 because 36 divided by 36 is 1. I end up with 9x squared over 36 minus 12y squared over 36 equals 1. This looks pretty good. All I have to do is simplify. And there's our solution. With the help of the calculator, a lot easier. X squared over 4 minus y squared over 3 equals 1. Snoopy has some words of wisdom for you. My only words are to try your best with 15D.